Hello everyone, so today in this video we are going to look at how to derive Michaelis Menten equation. So this is basically Michaelis Menten equation. So why are we finding Michaelis Menten equation is that because we want to find the enzymatic activity for a specific enzyme. So whether the enzyme is working to compare one enzyme and another enzyme, which one works better. So that is why it helps with Michaelis Menten equation. So in this video, we are going to look at how to derive Michaelis Menten equation. Okay, in order to get this Michaelis Menten equation, there are several steps that need to be worked on. So these are the main sub equations that we require in order to make this Michaelis Menten equation. So let us see the sub equations into detail one by one. So this one, okay, this one is Km is known as the Michaelis Menten constant. So the Menten constant is that it is equals to K minus -1 plus K2 divided by K1. So what is this is that we have to see the equation of enzyme reacting with substrate and forming enzyme substrate complex. So this is how the equation looks like. So first we have enzyme. This bracket is indicates that the concentration of the enzyme. So the concentration of enzyme reacts with the concentration of substrate becomes enzyme substrate complex, and then this enzyme substrate complex produces reactions, and then it becomes product. Okay, so this is the equation. So as we know, K stands for the rate constant. So the higher the K value, meaning that the rate is higher. So first of all, the enzyme concentration and substrate concentration react to become enzyme substrate complex. So this constant, this rate of reaction constant, we can put it as K1. So if this is K1, then when enzymes, this is a reversible reaction, so it might become enzyme and substrate again. So this constant will be K minus 1. Okay, so next enzyme substrate complex becomes product. So what constant we can put here is that K2. But then this reaction hardly becomes the product, hardly becomes enzyme substrate complex. So we uh, do not take this as a significant value. So this is basically the enzymatic reaction occurring in any kind of enzyme. So this is how we can derive the equation from here to making Michaelis Menten constant constant. So in a reaction pathway, we can equalize the reaction, the rate of formation of product or the rate of dissociation of the reactant. So here, these are the reactants. So we can set like dissociation, rate of dissociation of enzyme and substrate equals to rate of formation of enzyme substrate complex, and also the rate of formation of product. Okay, how can we make this into a numerical equation? Is that okay? So the rate of dissociation of rate of dissociation of E and S is the meaning of rate of formation of enzyme substrate complex. So first of all, we have to use K1, K -1, K2 in the equation. So the equation looks like this. So K1 rate constant times with enzyme concentration and then times with substrate concentration. These are the reactants equals to rate of formation of enzyme substrate complex. So here we have already used this K1 rate constant, and now we have to use K -1. So this one will be the rate of dissociation of enzyme substrate complex into enzyme and substrate. So K -1 enzyme substrate complex. So this one is the reactant for this rate of constant. So and then plus with which is, we can say this as rate of formation of product or rate of dissociation of enzyme substrate complex into product. So K2 enzyme substrate complex. So this will be the equation, and from this we use these four equations into forming Michaelis Menten equation. So yeah, okay, let me explain about this equation. So this one, enzyme total concentration. So in a solution or in a medium, there will be a total enzyme quantity, right? So the total enzyme quantity represents this concentration. The concentration of the total enzyme equals to the concentration of enzyme that is not bound with enzyme substrate complex. So this one is free enzymes plus with the enzyme substrate complex. So this is one equation that will be used in forming Michaelis Menten equation. So this one, okay, Vmax. So Vmax is a maximum velocity of an enzyme. So after that, the graph looks like this. Okay, so this one will be the substrate, and this one will be the velocity. Velocity meaning the rate of reaction, or how fast and how efficient the enzyme is working. So the graph basically looks like this because other factors become like, for this graph, the concentration of enzymes become the limited factor, causing it to become plateau. So plateau meaning it is going flat graph, which is the constant will be the rate constant will be 0. Yeah. So at this point, this is called maximum velocity, and the V or V naught is the minimum velocity. How the enzyme is starting, the starting velocity of the enzyme is known as V naught. So we are now about to begin with the deriving Michaelis Menten equation. So the first step will be, we have to come from this equation. So the first step will be enzyme substrate. So these are our reactants. Put K1, because this is the rate equation, equals to K -1 dissociation of enzyme substrate plus dissociation of enzyme substrate into product, K2 enzyme substrate. Okay, so this is the first step. Then, okay, in these equations that we are going to use, okay, the number of the presence of enzyme itself is very low. So in order to solve this equation, we have to change this lone enzyme concentration into enzyme substrate complex concentration, and also the total enzyme concentration. So if we make this enzyme concentration as the subject, so what will be the equation? Enzyme complex. So this one will go here, becomes and total enzyme concentration minus the concentration of enzyme substrate complex. So K1 E stands for, make it as big parentheses, enzyme. So total enzyme concentration minus enzyme substrate concentration, bracket substrate, equals to, we just repeat this, done. So next, solve this. Okay, here we can see one step ahead, where we can form K -1 plus K2. If we bring this whole K1 here, here, meaning that K -1 plus K2 divided by K1, which is the constant, we can straight away solve this by making the K constants into Km. So that's what we are going to do now. So enzyme substrate complex, here is the what do you call the that we can take out from the equation like this. So K minus 1 plus K2 enzyme substrate complex. So we can factorize, and then here we are going to bring the K1 down here. K1. So here enzyme total concentration, sorry, minus enzyme substrate, and then the substrate concentration. This whole thing equals to this. So now we can change this into Michaelis Menten constant, and then times with enzyme substrate concentration, and then this one. Okay, this one we can. So now what we can do? Okay, so now we have to form Michaelis Menten equation, right? So this will be the V max times with substrate divided by Km plus substrate. So we need to form this equation. So let us think. Okay, now we have already have Michaelis Menten constant, but then here, how are we going to solve this? So now here we have enzyme substrate, and here we have enzyme substrate. So we have to bring it to the same side. So now we have to solve this equation. So total enzyme concentration times with substrate minus enzyme substrate complex concentration times with substrate. So now we can bring this to the right hand side. So total enzyme concentration times with substrate concentration equals to Menten constant, and also enzyme substrate complex concentration plus this whole thing, enzyme substrate complex concentration, and then times with substrate concentration. So now we can factorize out the enzyme substrate complex concentration. So Km plus substrate times with enzyme substrate concentration. So as we can see now, this Km plus substrate concentration, it is in the Michaelis Menten equation. So this one is sorted. So now how we are going to form V naught and V max? If you can see, there is no V max and V naught in this equation. So in order to get, we have to use this for two equations actually, basically this one and then this equation. So in order to form this V naught and V max, we have to make this equation to form this and this equation. So first of all, in order to form V naught, okay, so do we have K2 here? No. But we do have enzyme substrate complex. So enzyme substrate complex. Okay, let me write this. So equals to. So we are going to convert enzyme substrate complex into V naught divided by K2. So Km plus substrate concentration whole thing times with V naught divided by K2. So this is going to be our subject in order to obtain Michaelis Menten equation. So now, okay, so let us keep this as our subject in the right hand side. So V naught, so whole thing. So this one is here is times. So here it will become divide. So enzyme substrate, enzyme total substrate concentration. So here enzyme total substrate concentration divided by Km plus substrate concentration, and this K2 over here comes here. So now can you see K2 enzyme so can you see K2 enzyme total concentration? K2 enzyme total concentration. So this whole thing over here becomes B max, and then this times with substrate divided by Km plus substrate equals to B naught. And this is the Michaelis Menten equation.